Cognition encompasses many aspects of intellectual functions and processes, such as, for instance, formation of knowledge, memory and working memory, judgment and evaluation, reasoning, problem-solving, and decision-making. The four AI subfields related to cognitive tasks are machine learning, knowledge representation and reasoning, planning and scheduling, and multi-agent systems. Machine learning, known as ML, is the study of computer algorithms that improve automatically through experience and by the use of data. Machine learning algorithms build a model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to do so. These data are usually generated by AI perception systems such as computer vision or natural language processing tools. Moreover, a subset of machine learning is closely related to computational statistics, which provide the main theoretical groundings. But not all machine learning is statistical learning. Data mining is a related field of study, focusing on exploratory data analysis through unsupervised learning. Let me mention that when applied to business problems, machine learning is also referred to as predictive or advanced analytics. Subdomains of machine learning include unsupervised learning, supervised learning, reinforcement learning, classification and regression, clustering, deep neural networks, evolutionary learning, online learning embeddings, quantum machine learning. Very common applications are prediction and forecast, for instance, sale and demand forecasting in markets, recommender systems, predictive maintenance, anomaly detection systems. We move from learning knowledge to reasoning on this knowledge. In particular, knowledge representation and reasoning, known as KRR, is the field of AI devoted to representing information about the world in a form that a computer system can use to solve complex tasks. Knowledge representation incorporates findings from psychology about how humans solve problems and represent knowledge in order to design formalism that will make complex systems easier to design and build. Knowledge representation and reasoning also incorporates findings from logic to automate various kinds of reasoning, such as the application of rules or the relations of sets and subsets. Subdomains of knowledge representation and reasoning include description logics, knowledge engineering, logic programming, ontologies, automated reasoning, and theorem proving. Very common applications are semantic web and expert systems. Once knowledge has been processed and some form of reasoning has been performed, we can move to planning. In particular, automated planning and scheduling is a branch of AI directed to the realization of strategies or action sequences, typically for execution by intelligent agents, autonomous robots, and unmanned vehicles. Planning is also related to decision theory. Planning requires organizing a set of tasks to achieve a given goal. In known environments, with available models, planning can be done offline. Solutions can be found and evaluated prior to execution. In dynamically unknown environments, the strategy often needs to be revised online. Solutions usually resort to iterative trial and error processes commonly seen in artificial intelligence, even exploiting learning tools. Subdomains of planning and scheduling include deterministic planning, optimization of spatio-temporal systems, plan execution and monitoring, planning, scheduling and learning, scheduling, temporal planning. Finally, we move to the scenario in which multiple AI entities interact, and therefore every AI entity needs to explicitly take into account the presence of other AI entities. In particular, a multi-agent system, MAS or self-organized system, is a computerized system composed of multiple interacting intelligent agents. Multi-agent systems can solve problems that are difficult or impossible for an individual agent or a monolithic system to solve. Intelligence may include methodic, functional, procedural approaches, algorithmic search, or reinforcement learning. Subdomains of multi-agent systems include adversarial agents, agreement, argumentation and negotiation, coordination and collaboration, distributed problem solving, mechanism design. Very common applications are automatic economic transactions by means of microeconomic models, resource allocation for physical security, decentralized control.